This is a little thing you guys might find useful. Some of you are probably already familiar with a feature called corner overcut. I'm not going to design anything in particular here. I just want to show you the basics of it, and then I want to show you something that I do that's a little bit different that I think helps with, let's start with something smaller so it makes sense. I do something a little bit different that makes for a little bit easier load on my cutters, and gives me a smaller effect from corner overcut. This would be a typical wrench cutout, just a hex wrench cutout, and you could pocket that out pretty simply. And then in old 2 or 3 versions ago in CamBam, there was a feature called corner overcut in pockets, and now that feature is only available for profiles. So you just click the same geometry and click profile. And if you're going to use the same tool for both, it's no big deal. You just come down here and you pick your tool. In this case, we'll use a 1/4 inch end mill. And we generate tool paths. Oh, we see we have a little error. That's one of the things that the guys are complaining about. Oh, you got to remember it's easy to make mistakes. Well, yeah, it is. And then if we go down here and find and turn corner overcut to true, Control T, you'll see that it cuts in enough so that anything that's put into that socket will reach as far as it needs to in that corner. And that's all well and good. But let's take a look at the cut width for that 1/4 inch cutter. You see we got a huge lobe there. All right. And that's, again, not that big a deal, but depending on what you're doing, some people might really object to that big old huge lobe in their hex wrench. So let's turn the cut widths back off, and let's create. And what I do is I just do it with a smaller cutter. So we'll just copy this, and we'll turn that one off for now, and we'll come down here and we'll change it to 1/8 inch. Or whatever's convenient for you. And you see we get the corner overcut, and if we show the cut width, we can see that the lobes are, maybe I didn't get the toolpath changed, the tool cutter size changed in the right operation. You can see the little lobes on the corners are much smaller, and most people would probably not even notice those. Anyway, let's turn the cut width view off. You can see you got the little cut there, but we're using a tool that's several times smaller in cross section than we were before, and we're doing 100% engagement as we plunge into those corners. And if you're doing a one-off part and you're only doing one of them, and it probably doesn't matter if you do that. It's no big deal. You just run the whole thing slow enough so that it's capable. Here, let's turn the pocket off so you can see the tool path for the cleanup profile. You're doing one pass to depth, and you just run the whole thing slow enough that 100% engagement of the tool in the corners isn't going to break the tool or cause excessive deflection. But I found a little trick that allows me to go a little bit faster if it's a part that I'm going to make more than once. That's an 1/8 inch tool, so let's do this. And I have the Snappy Points plugin installed, so it allows me to move things to points, not just to grid. So I'll snap there, go there, and then I'll copy that around. Five copies, 60 degrees around, boom. Alright, let's take all these circles and move them down here. And we'll make this our active layer. Alright. And let's vanish that for the moment. Control A to select everything shown. Edit. Break at intersections. Okay. Yeah, I know, this part's tedious. Sometimes to make something run faster, you have to work on it a little bit longer before you get there. Alright, Control A to select all, edit, join, OK. Now what we have is a shape that includes those extra overcuts in the corners, so that when we profile it, we'll get the same result. And you'd say, well, yeah, we get the same result. What's the point of all that effort? Well, let me show you. Let's go down here, and let's select this for that operation. Control T to generate toolpaths, and as you can see, it's a lot less aggressive as it goes into each of those corners, and you might be able to program the operation to run a little faster. Now, I showed you two things in this, and one is that if you do your cleanup and overcut with a smaller cutter, you're going to get the clearance results you need with less obnoxious overcut. And also, if you create a shape like what you need, or what you're going to wind up with, instead of just letting the software do it for you, then you wind up with a little bit less aggressive cut, and you may be able to program the operation to run a little bit faster. Here, let's turn this one on and set it to the same tool. I think I already did, yep. And that one is working with this tool. Let's zoom in on one of those corners there. And as you can see, this is a whole lot less load on that tool than this is. I don't think you're ever going to get 100% engagement of that tool as you ease in and ease out of that corner for your overcut. Where here, you're going to get 100% leading edge of that tool from here to here as it bottoms out, or I should sidewayses out, I guess. So that's something that might be worth it for you, especially if you're going to be making multiple parts like this. I actually came up with this method for making wrenches because I make some speed wrenches for sale. Haven't sold any, but I make some speed wrenches for sale for different size vices, and this was a useful technique for me, and it helped me to run my operations faster and be a little more efficient. And it makes a difference for me because I have to do 2 of these hexes on every speed wrench, and I run anywhere from 5 to 10 speed wrenches at a time when I'm making them. So take it for what it's worth. It may be useful to you, it may not. Merry Christmas, Happy New Year, all that stuff. If it's the middle of summer, well, when the next Christmas comes around, Merry Christmas, Happy New Year. Have a great day, guys.